Today we are going to look more at problems where they don't provide us with a diagram and we have to kind of draw our own diagram and make sense of the problem. Okay, so we are going to start with this one over here. Okay, so let's have a read of the problem. I'm going to keep quiet for a minute or two while you guys read. Remember last week, and for those who are new, when you are done reading, then you post your reading face. Okay, so you read the question and then you post your reading emoji when you are finished reading. So then I know you've read the question and we can actually start doing it. Okay, so remember that thing about participation. I want everyone to participate. When I ask for emojis, post your emojis. When I ask for answers to questions, post them in the chat. Okay, so participate as much as you can. All right, so start reading the question and I'm going to keep quiet. I'm going to try. Unka Rabile, I am going to post the top 10 quiz list next Tuesday, because today you are doing a quiz again, and I'll post for the new quiz that you're doing today, I'll post it on Tuesday, the top 10. Thanks for reminding me. Okay, some of you are reading very quick. Make sure that you understand nicely what you've read.
Wow.
Unati, it's okay. If you want to post the cool emoji, that's fine. We understand. Okay, looks like most of you read the problem. So, okay, so now what happens if you don't understand? Then you read it again, okay? And then you start highlighting for yourself some important parts, okay? So let's see. A zip line ride starts 30 meters above the ground. The length of the cable is 100 meters. Assuming the zipline ride is fixed to the ground, calculate the angle that the cable makes with the ground. Okay, so just to remind everyone, please stay on mute, just to avoid any background noise. So, has anyone here gone ziplining? Has anyone gone ziplining? Who's done it? Post in the chat if you've done it. Larata's done it. And Kamu and Unati zipline. Okay, awesome. So basically what it is and blessings. So there's a few of you, very adventurous, great things that you've gone on zip lines before. I also did it when I was much younger. But basically they put you in a harness and there's a cable that goes from like a high point, either like a tree or a cliff or something. And they strap you in and you hold on to these bars and then you basically slide down this cable to the bottom. So it's obviously very fast, it's very high, so it's quite an adrenaline rush. And yeah, it's not something that I would actually be keen to do, not now in my old age, but I think while you're young you must try things. Okay, so now that we know what zip lining is, I hope that gives you a better idea of the picture that we are going to draw, because that's going to be our next step, is to draw a picture of this problem. And here in this bubble, I made some notes for you about how to approach a problem like that. Sunday, I will be with you just now. I'm just going to finish explaining. Okay, so a zip line, right? So this is going to be your next step. A zipline ride starts 30 meters above the ground. Okay, then the length of the cable is 100 meters. So that cable length of the zip line, that is 100 meters. Assuming the zip line ride is fixed to the ground, calculate the angle that the cable makes with the ground. So now that I've described to you that it comes from a high point, and in this case, that point is 30 meters above the ground, and there's your cable, and it's coming down, and it's fixed to the ground. At what angle is that happening? Okay, so I want you to, first of all, visualize this situation. And you don't have to have been ziplining before to actually understand the question, okay? It's just about a cable that is running from a high point to a low point, and it's making an angle. So visualize the situation, and then I want you to put your artist cap on and draw. Make a simple representation of the problem, an easy diagram of a very simple diagram of what the situation is. Okay, so I'm going to give you about a minute to do that. Just visualize and then draw it. Just picture it and then draw it. And remember, we are doing trigonometry, so it is going to be a right angle triangle of sorts. And you can even, if you already go as far as to label your sides and label your angles, in other words, put your measurements in. Okay, so I'm going to keep quiet now again, and you draw, best artist, and I won't be able to see what you get, but you will be able to compare yours to mine. Okay, right. I think I might have flashed the picture there, but let's see. So I also want you to take down these tips for how to solve these problems. Okay, visualize, draw, label the sides, label the angles, check and solve. Okay, so let's first start. We are starting at a point that is 30 meters above the ground. And because it is 30 meters above the ground, it is making a right angle with the ground. Okay, so wherever you're ziplining from, that is 30 meters high. And then that cable that goes from where you're going to zipline from to the point where it ends, that cable is 100 meters. Now, it says that we have to calculate the angle that the cable makes with the ground. So this is basically, that represents your cable. And here is the point that you're ziplining from, your starting point. And this is the ground, Mother Earth, and you are 30 meters above. Okay, so I want you to put in the chat, how did that go? How does your, give me a thumbs up if your picture looked a bit like mine. Thumbs down if you weren't sure. Let's see. Nice, I got quite a few thumbs up coming through. Excellent. Okay, so our angle that we are solving for is going to be called theta or X, whatever you want to call it. Just give it a label name. And I'm going to show you the picture that came from the book. There we go. That's a nice, nice visual of what ziplining looks like for those of you who haven't done it yet. Okay, so now we have to solve for our angle, which is theta. And our next step is going to be to label our sides. So if this is 90 degrees, then across from the 90 degrees is the hypotenuse side. Across from theta, my angle, that's the opposite side. And then the side that's next to my angle is the adjacent side. Okay, so that's what we've been going over a few times now in the past few lessons, labeling our sides. So which trig ratio is are we going to use to solve for theta? Okay, Alexandra says sine. Okay, a few of you are saying sine. Okay, and why would we be using sine? Sine, because we have two sides that are known, 30 and 100, and they are the opposite and the hypotenuse side. So that's why we say sine of theta is going to be 30 over 100. So that's your trig ratio that you identify. Leni, we are not going to use cos because cos is the adjacent and hypotenuse side. And if we use cos, we have too many unknowns. We need two sides if we want to solve for an angle using trigonometry. Okay, so on your calculator and post in the chat when you have your answer for theta. If you are new and you're joining for the first time, remember all our lessons are recorded and you can access them on our website. Our quizzes are there as well. But this lesson, I'm sure if you follow along and just listen carefully to the explanations, you will definitely catch on because you've done trigonometry before. So it's not entirely new. So just try and follow along if you are new and this is your first lesson, but definitely access the recordings that we've got of the previous 3 lessons. You can do that. Okay, so everyone's saying 17,5 and we have to round to 1 decimal place. So let's see if that is correct. Shift sign 30 over 100. That gives me 17,45, which we are going to round 1 decimal place. Not 14, 17,5. Well done to those of you who got it right. And if you didn't get it right this time, don't stress. There is another chance to do it, to do the next question. So let's see what the next one is about. And I want you to do the same story. Read the question. Post your reading face emoji when you are done. Okay, wonderful. Quite a few of you have finished reading, so I'll just give a quick explanation. Nandi walks 50 meters from the bell tower door across the playground. Okay, so obviously this is at her school. There's a bell tower, and she walks from that tower to the playground. Let's highlight the important things. So 50 meters from the bell tower across the playground. She measures the angle to the top of the school's bell tower from the ground as 34 degrees. So top of the school's bell tower, 34 degrees. Calculate the height of the bell tower X. giving your answer correct to 2, not significant figures. We're going to do it to 2 decimal places. Okay, so same story, visualize the situation. Yes, so Mokoko-Bali, don't worry about that. We do 2 decimal places. So visualize, draw, then put your measurements in and label your sides, check and solve using your correct trig ratio. Okay, we are going to check back in about 2 minutes time at 17:26 to see how you are doing. Just by the way, grade 10s, while you're working, don't post any answers in the chat for this one yet. Just work on your own and I will ask for answers. So only post them when I ask, please. Okay, let's have a look. Let's see how your pictures turned out. I'm going to get this very nice picture that came from the worksheet that I got this from. So it's in a lot of detail. But there's Nandi, and she's walked 50 meters. And she's looking up at the bell tower at an angle of 34 degrees. And we are going to calculate the height of that bell tower, which is x. So I'm just going to draw like a simple diagram of the situation, just like this, because we can't really see so much on that one. So here's my 34. This is going to be my x, the height, and this is 50. So I label my sides, opposite, adjacent, hypotenuse, and we need to now solve for a side. So previous question, we solved for an angle. So that is why we use 2 sides. Now we are solving for another side. So we need to use our angle and the side that was given and the side that we need. So the side that was given is 50. The side that we need is the opposite side. Adjacent and opposite together, that gives us tan. So we are going to do tan of 34 degrees is x divided by 50. Okay, and we use tan because it is the side that you are looking for, x, which is the opposite side, and the side that you want. Sorry, the side that you're looking for, which is the side that is x, and the side that's given is 50. And then times by 50 on both sides, and that gives you 50 times tan 34, and that is 33,73. Okay, give me a thumbs up if that is what you got. Thumbs up. Nice and in Basa. Anyone else? There's some other thumbs up here in the Zoom. Good stuff. Excellent. Right, well done, everyone. Really, I hope you are checking your answer and understanding where you're going wrong. Make sure you use the right trig ratio. Make sure you place your sides, your measurements and everything in the right place on your diagram. Okay. Right, so if you're still struggling a little bit, don't worry. We have got more questions for you to do. Okay, let's go. Here's another one. Okay, try again, everyone. Those of you who didn't quite get it right, let's try again. Same as last, let's read. Let's put our reading faces on if you're done. Manzini, I'm not sure what you mean by expanding. I'm going to briefly go back to that question for number 2. Not sure what you mean with expanding, because that's pretty much it. You go tan 34 is equal to x over 50. And people are posting reading faces, but I haven't posted the question's gone. So I don't know what you're reading. So tan 35, just that could be, maybe you mean you go 50 times tan 34 equal to x. And that you do on your calculator. Okay. But if you have more questions, Manzini, let us know. Try and be a little bit more specific in your question if there's a part you don't understand. Okay. So reading faces, let's see. Okay. Well done, everyone. You're good with your emojis this evening. Don't feel rushed to read. Finish reading. And I'm going to start giving a little bit of an explanation so long, but you guys need to know that after this, you start looking for some keywords and some important information, highlighting the important information, and then you visualize and then you start drawing. Okay, so a ladder is leaning against a wall. The base of the ladder is 3 meters from the base of the wall. Okay, so this is important. And the ladder is 5 meters long. Calculate the angle. We are going to calculate the angle, that's important, that the ladder makes with the ground. Okay. Give your answer correct to the nearest whole number. Right. So visualize the situation and then make a drawing of what you think it's going to look like. Put the measurements in and then select the right trig ratio to solve for the angle. So already, knowing that we are going to solve for an angle, you're definitely going to use 2 sides to solve for the angle. Okay, we're going to check back here at 1735, see how you're doing. And remember, if you're wondering about something, post your question in the chat. Let us know if there's something you're wondering about. I wonder how those drawings are looking. Ms. Coco, what do you think?
Well, I bet you they look better than ours, Teacher Marlies. We also don't draw quite that well. In our defense, we don't have rulers like they do when we draw on our screen.
Yeah.
So,
I hope people are drawing with rulers.
yes.
I kind of neglected to say that you need your ruler. Okay, so Leah, like when to use tan or sine. Okay, so it all depends on the sides. So first draw your triangle, and then if you are using, it depends on your sides. Remember, if you have the opposite, so if it's SOHCAHTOA, then it's opposite over hypotenuse. So then you're going to use those two sides with sine. And if you've got two sides and they are in the adjacent and the hypotenuse, if those two sides are given, then you use cos. And if you have the opposite and the adjacent side, then you use tan. So it all depends on what sides you have. And in this case, we're solving for an angle. So depending on where the 3 meters and the 5 meters are in terms of opposite, adjacent, hypotenuse, whatever combination they are in, that is the trig ratio that you use. But you're welcome to hold on a little bit, and then I can explain a bit more, and then maybe it'll help you to understand. Okay, so we've got a wall. I'm going to draw that first. And then there is a ladder leaning against this wall. And the base of the ladder is 3 meters from the base of the wall. So here's my ladder leaning. And this distance is 3 meters. And the ladder is 5 meters long. So I've drawn my ladder over here. So that measurement is 5 meters. Calculate the angle the ladder makes with the ground. So this is the ground over here, and that's the ladder. So the angle between the ground and the ladder, that's going to be theta. Okay, so that's why it's important to follow the steps, Leah, so that you picture it, you make a diagram of the situation, and now we're going to label our sides. So this is my opposite side because it is across from my angle that I'm trying to find, theta. Across from the right angle is the hypotenuse side, and next to the angle is the adjacent side. Now, since we're solving for an angle, we need two sides. And in this case, we're going to use the two sides that we have values for, which is the 3 meter and the 5 meter. So that's adjacent and hypotenuse. So we are going to do cos. So we say cos of theta is adjacent over hypotenuse, that's 3 over 5. And because we know what the ratio is, we can just use our calculator to tell us what the angle is. So shift cos 3 over 5. That gives us theta is 53,13 degrees. Oh, we must round to the, I'm so used to rounding to 2 decimal places that I forget. So we must round to a whole number. Okay, right, who got that one correct? Put a thumbs up in the chat. Let's see. Who got it right start to finish? I wonder. And I wish I was there, Miss Coco, to see those beautiful drawings of ladders and the ground.
I know. And they're getting the work right, so it must look amazing.
So Buchle is saying, I did everything the way you did, but my answer is not the same. Remember, Buchle, to check your calculator is showing that capital letter D, that it's not in some funny mode that's giving you different answers. If you did it exactly like we did, then you should get 53. Did you press shift cos? Not cos 3/7, but shift cos. Don't forget, if we are working back to get the angle, if we have the ratio, then you have to press shift. Buchle, I hope you remember to press shift. Okay, Ayanda, a few of you are saying you are still not sure. Okay, so here's one more before we go to our quiz, and let's have another look. Same as before. There we go. Okay, problem solved. I'm so relieved, Buchle. Remember to press shift. All good. Yay. Okay. Last one. Again, put your reading faces in the chat when you are finished reading, and then go for it. Draw, label sides. Let's see if we can all get this one together. While everyone's working, Omhle, you can ask your question. Oh, it's gone. Okay. Okay, just post your reading faces so that I know you've read it, and then I'll do a brief explanation. But I don't think you guys need an explanation of this one. I think you guys are catching on very nicely. If you're still a little bit lost, give it a go. Just try. Just look at what we did in the previous question. See if you can apply it here. Right, Mpumelelo, you've got a question. Go for it. Unmute and ask. Everyone else, carry on working. Yes, Mpumelelo.
Ma'am, can I ask that how to find sine theta in calculator, or in the theta you put 0 in brackets?
Can you repeat your question, please?
In sine theta, ma'am. Then there is if you say cos, then there is theta. You put 0 inside of the brackets, or
Oh no. So if you're solving for an angle like we did here, you can't put the theta in. You have to say shift cos 3/5 on your calculator. So you press shift and then the cos button, and then 3/5 using the fraction button. You see, and equals,
yes,
and then it's going to give you 53 degrees.
Yes.
Okay. Okay, so lots of people have finished reading. Lots of people have finished reading. Remember, guys, questions are addressed to me, so I will answer them. You just carry on doing your work with the ladder question. So a ladder is 6 meters in length and is placed against the wall. So very similar to the previous question. The bottom of the ladder meets the ground at 75 degrees. How high up the wall does the ladder reach? Give your answer correct to 1 decimal place. Okay. So there was a bit of chattering going on while you had to think. But let's give this last question 1 more minute, and then we're going to do it. I want to see that everyone tries this question, and let's see if we can all do it right. Yeah, so I think what Ayanda is trying to say is you only use shift when you are solving for an angle. When you know what the trig ratio is, but you want to know what the angle is, then you use shift. If you want to find out what the value of an angle is, cos, sine, or tan, then you don't use shift. Okay, so check that your diagram looks a bit like this one. So the ladder is 6 meters long, and there's an angle of 75 that the ladder makes with the ground, and we want to find out how high it reaches up this wall. Yes, Leah, go ahead, ask your question.
So ma'am, if you're given an angle and a side, you use 10.
Well, it depends. We have to just make sure that we are using the right combination of sides. So we use our side that we are solving for, which is the opposite side. And the side that we have is hypotenuse. There isn't any one single trig ratio that you're going to use every time. It's all going to depend on your sides, the side that you have and the side that you want, and where they are placed in your triangle. If it's the opposite in the hypotenuse, or the adjacent in hypotenuse, or the opposite in adjacent. Okay, so you can't say we are always going to use tan. It depends on your sides. So in this case, Leah, what do you think? We are solving for the opposite side, and we have a value for the hypotenuse side. So if it's opposite in hypotenuse, which trig ratio do you think we're going to use?
Sin, ma'am.
That's
Sine.
right. That's right. Okay. So we go sine of 75, and that is x over 6 meters. And then we times by 6. And remember, if you get lots of square root signs and stuff on your calculator as an answer, there's a button that looks like this, SD. Just that will change it. If you press that button, it will change it to a decimal for you. Okay, so we are rounding to 1 decimal place. So we are going to make that 5,8. Okay, wonderful.